initial volume. And it is 3.11. Putting it here. And the final volume is 2.2.
So we're basically going to use this 10 milliliter graduated pipette. We're going to suck up blue solution so you're able to see the difference from the initial volume going to the final volume. So we're going to use this bowl to suck up the blue water. So when we sucked up the blue water the first time, we reached it at eye level to about 6.9. You need to measure from the top to down. Yeah, right here.
So it's a little less than 5.
So it's going to be 5.1. You want to use that. And we're just gonna put it into this little thing right here. So we're just gonna after I transferred some of the solution from the graduated pipette into this little bowl thing, which I did, and at eye level it is now about 7.7.
Six point 6.85.
Backwards. All right, so our stock solution is prepared to make solutions of lesser concentration from it, and our dilution makes less concentration as well, but we're actually going to use stock solution. And our dilution equation is C1 times V1 equals C2 times V2, or initial concentration times initial volume equals final concentration times final volume. So we have to manipulate our variables to solve for what we're looking for. In this example, we have 5.03 milliliters of 20% sugar stock, which is going to be transferred into 25.0 milliliter flask. So we've properly identified our variables. So 5.03 milliliters is going to be our initial volume, 20% sugar stock is going to be our initial concentration, and our final volume is going to be 25.0 milliliters. So we've identified all of our variables, so we end up looking for our C2, or our final concentration. So we have to manipulate our equation. So now we're going to have 20% initial concentration multiplied by 5.03 milliliters, our initial volume, and divide that by our 25.0 milliliters, which is our final volume. And when we identified our concentration, we realized that our C2 is 0.0402, but we multiply it by 100 to get back to our percent, so our final concentration is 4.02%.
Meniscus is the dip of the liquid inside a measuring container, and the way you measure it is you measure the bottom of this dip, and that is the meniscus, and a little bit of a decimal away from that to make sure that you know why. You can explain.
You get the error, so you can adjust for error. So the meniscus forms from the adhesion to the side and the surface tension of the water, causing a dip, which you then use the level of the dip to find the measurements.